Alright, so today we have Polynomials Equations Guided Practice, and this is regarding the solutions for the color activity, but also great opportunity to get some neat examples into your notes as to different ways that you can solve types of polynomials. So let's go ahead and look at number 1. So we have our setup of the equation itself, and some of the pattern is to look for what basically is always number 1. What are the options usually for number 2? What are our steps that we're going to be kind of running through? So first thing you have to do is set it equal to 0, taking in this case the difference of those to both sides. Okay, so we get our new equation. And then the question is, now out of all the different resources, what can you use? Can you use greatest common factor? Can you use factoring, difference of two cubes, sum of two cubes, quadratic formula, anything along those lines? Those are all we're going to be looking at, is which tool can we use to help us simplify this. So most commonly, we're going to start with our second step of, can you use the greatest common factor? And yes, you can. So now that we're in this situation, again, we ask ourselves the questions. Can I factor? Can I use difference of two cubes? Can I use sum of two cubes? Is it a difference of two squares? Quadratic formula. What are all my possibilities? Yes, no, yes, no. And the answer is basically, I can just simplify. There's none of those apply to it. So I'm going to set both pieces equal to 0 and solve and find what x could equal. Alright, so let's look at our next problem. Move up. So number 2, we have our equation. First step is going to repeat. Set it equal to 0. First and foremost, always an indefinite in these type of situations. So then you start asking yourself, can I use greatest common factor? Yes, no. And the answer is yes. Alright, now that I've used the greatest common factor, then you start looking inside the parentheses. What can I do to simplify inside there? Again, difference of two cubes, sum of two cubes, difference of two squares, quadratic formula, standard factoring, etc., etc. So we can actually use factor. So we're going to take the multiples of a times c and say, given that, how would they combine to give us b? And this is given our standard formula of a n squared plus b n plus c, basically, or minus c. So we take our 4 and our times by our negative 6, get negative 24, and then say, okay, what are factors? And since it's a negative, that means we're going to take the difference between the two numbers. Basically, going to subtract. One of them is going to be negative, one's going to be positive, so a difference that gives us 5. So we list all the factors of 24 and go, well, there you go. 8 and 3 give me a difference of 5, which is my b that I need. Okay. So now you have two options that you could do. For this situation, we are just going to actually plug it into our factors. Say from, okay, so from a and 3 from factors of, so we're going to try to form these numbers. How do I form an 8 and a 3 if I have a 4 and a 6 and the factors of those two numbers? So I can rewrite negative 6 as negative 3 times 2. That's my last, if I use my FOIL concept, would give me my negative 6. And 4 times 1. But when I do my inners and my outers, I get an 8n and a negative 3n. So that's kind of what you have to look at. It's like I need an 8 and a negative 3 from the factors of 4 and 6. How can I arrange those to get those numbers? So these are some neat tricks on how to be able to find out that information, have in your book and your notes, and use them as a reference point. So now we can't simplify any further within either one of those. So we set them equal to 0 and solve. And get our answer. Number 3. To the 4th power. So we're going to be kind of looking at what are our options from there. First and foremost, set it equal to 0 by subtracting to both sides and getting our new equation. So from there we go, right, can I do greatest common factor? No. So then my next question is, how can I simplify this? What tool and resource can I use to simplify it? And this is a trick that I'm going to show you here, is we can say, well, actually, again, just like the last time, we can find its factors by doing A times C and what combination gives me B. So I multiply my A times my C, get negative 8. So how are my factors able to combine? And since it's a negative, I need my difference to get 7. And which one of these gives me a difference of 7? 1 and 8. Now here's a neat thing that we're going to do a little bit differently this time. You can actually rewrite using the difference of the factors. So last time, otherwise, these would normally combine like terms and get me my 7k squared. But I can actually write this so it's the step before I combined like terms. So I have my 8x squared, my negative 1, k squared minus 8 equals 0. So when I set it up this way, I can now actually rearrange them. And again, this is showing the different tricks in the way that you can manipulate these problems. It's not just one set solution always. You can go from step 2 to step 3 here, or just like we did in the last problem. So I can actually rearrange them to put the terms next to each other that would allow me to do factor by grouping. And I'm going to go ahead and scoot this up. So again, this just shows my step before I would have combined like terms. And so now I can factor by grouping, factor out, factor out, factor out. And so now I'm at this point here. And again, I'm going to say, okay, what resource can I use in this one here and or this one here to have them be equal to 0? So I'm going to look at this one and say, okay, well, that's actually a difference of 2 squares. So I'm going to resimplify that down as a difference of 2 squares. Then I can look over here. So I've simplified those. What about this one? Can I do anything on that one? No. All right. So now I'm going to set each equal to 0 and solve. So the first two are pretty simple. The last one I have to solve using a square. I'm going to go ahead and scoot this up. And the square root. Which means I'm going to factor it and bring it out and then have my answers. All right, let's Let's look at our next problem. Set it equal to 0. Second step, can I factor out any greatest common factors? And yes, I can. The third step is starting my simplifying process. So, of all the different ways that you can go about it, which one do you want to use? And this is one way that you can solve it. Are there different ways? Yes. But I'm showing you different forms. So you can factor. So we need differences of negative 50, the difference of 50 basically, that equals 23. So which factor has the difference of 23? Negative 2 and 25 are the factors. Right? So I can plug those back in and write them. Again, using the step before, I would have combined like terms to get that 23r squared. And this situation, I don't need to rearrange them in order to do factor by grouping because I already have them next to each other. So sometimes you might need to, sometimes you might not. But I can automatically go into factor by grouping. And then you have to ask yourself, can you do anything else to this guy here or this guy here? And the answer is no. This one is not a difference of 2 squares. There's nothing that I can do here and apply any of my rules on that one. So it's just a matter of set equal to 0 and solve. So I get my first one. I set my second factor equal to 0. And solve. And then I get my answer. Alright, so let's look at number 5. Alright, first step as always, get it set equal to 0. And then from there, start asking, can you do any type of greatest common factors? What can I do to start simplifying this? Well, hey, look, I can do factor by grouping, nice and easy right off the bat, and start doing exactly that. Pulling out a negative 4. Remember, this is a tricky point here, that you have to do plus negative 4w. That negative 4 goes with that w. But then you can pull out a negative from both of these. So you have to change the sign here because you're dividing both terms by a negative. Make sure that these are correct and the same. Factor those out. And then you go, okay, can I simplify this one or this one using any of my ways of simplifying and factoring? And yes, this one is actually a difference of 2 squares. So I can rewrite it as its factors. This guy didn't change because there's nothing I can do with him. I can't simplify any of these any further. So I'm going to set them each equal to 0 and solve to get my solution. Right, scoop this up. Let's look at number 6. So take a wild guess what the first step is going to be. Set equal to 0. And then it's already, again, there's a set of factors here, there's a set of factors here. I can do factor by grouping. And then check to see if you can factor either. So again, can I do anything with this one? Is it a difference of 2 cubes? Can I factor it? Can I use quadratic formula? It's a difference of 2 squares. Anything along those lines. Same question you ask yourself here. Again, it has to be a difference of two squares. This is the sum of two squares. So, nope. So I just set them equal to 0 and start solving. And get my answer. Alright, let's look at the next one. Okay, so on this one, again, for number 7, our first step is going to be the same as always. And then we ask ourselves, how can we do it? Hey, look, it's actually a difference of two squares. And that's because you can rewrite y to the 4th as the square of y squared, and negative 400 is the square of 20. 20 times negative 20. So you factor, and then you ask yourself again, can I do anything to simplify this one? Can I do anything to simplify this one using any of our means? And our answer is no, so we can't factor each of those individually any further. So we set them equal to 0 and simplify. And solve. And set equal to 0 and solve and get our two answers. All right, let's look at number 8. Okay, so number 8, right off the bat, I have an a to the 3rd, which makes me suspicious that this is going to be a sum of two cubes. So let's set equal to 0, and I get 64, and 64 is a cube. It is the cube of 4. So I'm going to plug that into our formulas after identifying our a and our b. And simplify, just like you would do with any other situations of sum of two cubes. And this one can't be simplified any further, so I'm looking in here and going to try to simplify this of my different ways that I can do it. I can either do it in factor, I can do quadratic formula, etc., etc. How can I go about to simplify that one even further? And I'm choosing to do quadratic formula because I can't think of factors of 16 that add up to equal negative 4. Doesn't work. So that's why I chose to do quadratic formula. So identify my a, b, and c. Here's my formula. I plug them in. And so right now I'm setting this equal to 0. Basically is what I'm doing to try to solve for this quantity here. I'm going to scoot up. And I'm going to start simplifying. And I just kind of put this guy off to the side because you need to remember that he still exists in part of this equation. We're basically focusing on setting this one equal to 0, but I did want you to remember him. So I simplify, I can say, hey look, there's a perfect square that goes into negative 48, which is 16. 16 can be square rooted to give me 4. And then only things outside of the radical can be simplified by this denominator here. And thus I get that answer there. This one has already been set equal to 0 and solved, so we just need to do that now to get rid of our variable here and figure out that one. And thus we get our answer. Alright, let's look at number 9. Alright, so again, I have a cube, so I'm looking at probably the difference of two cubes right off the bat. That's where my brain is going. So I'm going to set equal to 0. And hey, look, I can actually factor out a greatest common factor. And then it is, in fact, a difference of two cubes because 8 is the cube of 2. So I can plug it into the formula. I already simplified. There's no factors of 4 that add to equal 2. So again, I'm just choosing to go with the quadratic formula. Identify my A, B, and C and start solving. I'm going to scoot this up. Simplify. Let's go and scoot this up. And then I have that. I'm going to set this other one equal to 0 because I've already set that equal to 0 to get that answer. And that's my answer. Okay. All right, let's go ahead and look at number 10. So I have these values here. I'm going to set equal to 0. And I get that. I'm going to say, okay, can I do any greatest common factors? Yes, I can. And now I'm looking at cubes. So I have the sum of two cubes, because don't forget, 1 can actually be written as a square, a cube. It's very versatile. And that component, 27, is the cube of 3. So basically my A becomes 3p, because that altogether is what's being cubed. And my B is 1. Substitute those into the equation, and I get this value here. Again, I can't factor, I can't do that in here, so I am forced to once more use the quadratic formula. Plug it in. Down here we have 2 times 9. I'm going to scoot up. Simplify. Simplify. Factor. Take the square root of my factors. Now I can divide my outside here. Remember, this is basically 3 divided by 18, or 3/18 being rewritten and simplified. And the same thing here, 3/18 being simplified, which simplifies down to 1/6. I'm going to then set my last other piece equal to 0 and get my answers. Alright, so I hope this helped.